Hello class, today we are taking a look at our surface area formulas practice. So when we are finding the surface area of a shape by applying the surface area formulas, we need to do a few things to communicate our work. We do need to label our diagram measurements with our variables appropriate for that object. We are going to need to write down the formula that we're using, and this is memorized off of our interactive notebook. We need to substitute our measurements into the formula, and then we need the solution with our correct units. On this particular handout, we're asked to round our answers to the nearest tenth. So in the case of the first question, I recognize that this object here is a rectangular prism. And I know that a rectangular prism has a length across the front, a width going back into the page, and a height going vertically. So that is labeling the diagram with our variables for this rectangular prism. Now my surface area formula for a rectangular prism is 2 of the length times the width plus 2 of the length times the height plus another 2 of the width times the height. And so that's the formula written down on my page, and that should be something that you're working to memorize so you can apply it on the exam. So let's fill in those numbers. I'm going to write down all these 2's and plus signs since they're from the formula and don't change. I said on my diagram that my length is 2 centimeters, so I'll fill in a 2 in all the length spots. I said on my diagram that my width is 5, so I'll fill in a 5 in all the width spots. And I said on my diagram that my h is a 4, so I'll put my 4 in the h spots. And remember that anywhere in this formula, each of our measurements should only appear twice. So I've got 2 reds, 2 blues, and 2 greens, and so I do know that those are all in the correct amount of places. So let's do our calculations. Now we could use our calculator, of course, but this is all whole numbers, so it should be nice and easy to do by hand. So 2 times 2 is 4, times 5 would be 20. 2 times 2 is 4, times another 4 is 16, and 2 times 5 is 10, times 4 is 40. Let's do our 20 plus our 40 first. That would give us 60, plus 10 would be 70, plus 6 would be 76. Now, since this is a surface area, we know areas have units of centimeters squared, so our final answer will be 76 centimeters squared for question 1. In question 2, this is a triangular prism. And a triangular prism, of course, the main part of it is a triangle. We know in a triangle that the key measurements are the base and the height, and they are connected by the right angle in that triangle. And I know that the base will be an actual side of that triangle, while the height is typically a dotted line, except in the case of a right triangle, where that dotted line would be shared with an actual side of the triangle. The other 2 sides of the triangle, which are given to us here and here, are our x and our y, and it doesn't really matter which one is which. I'm going to call x this 4.2, which I know, of course, is also 4.2 over here. And I'm going to call that 3.6 the y, just so it matches with what we did in our notes. That leaves our last one being the distance between our triangles, and that is called our length of our triangular prism. So that is labeling all of the dimensions. Now our surface area formula for a triangular prism is BH. That accounts for both of the triangular front and back. Obviously one of those triangles would be half a BH, but 2 halves makes 1 whole BH. Plus our bottom face is LB, L long by B wide. Plus our left roof is LX, and our left roof is LY. So that's our formula. Let's go ahead and substitute into that. We said on the diagram that B was 5, so I'll fill in a 5 into each of those B spots. We said H was 3, and in this formula there's only one spot that has that H. We said L was 7, and we've got 3 spots to fill that into. We said X was 4.2, and only one spot for that. And Y was 3.6, and again only one spot for that, I'll just come back and fill in those plus signs. So let's calculate each part of that. 5 times 3, that's easy, that's 15. 7 times 5 is easy, that's 35. 7 times 4.2 is a little bit harder, so of course we could use our calculators for that. If you didn't have a calculator, that is certainly something you can multiply by hand. And then our 7 times our 3.6 gives us our 25.2. We need to add all of those together to get our overall surface area. So we'll take our 25.2, we'll add our 29.4, we'll add our 35, and we'll add our 15, and that gives us 104.6 centimeters squared. Moving on to our cylinder. In this case, well, it is a cylinder, and we know a cylinder, the key measurements are the radius of the circle, as well as the height between the circles. So that's our measurements labeled. Let's write down our formula that the surface area of a cylinder is equal to 2 times pi times r squared, and that takes care of our two circles, plus 2 times pi times r times h, and that takes care of our curved rectangle, whose one side is the circumference of the cylinder, that's the 2 pi r, and whose other side is the height of the cylinder. So that's our formula. Let's substitute into it. 2 is just 2. I know that pi is 3.14. In this cylinder, our radius is 4, and we need to square that in that part of the formula. 2 is just 2 again. Pi is 3.14. R, we said, is 4, and it is not squared in this part of the formula. And then h, we said, is 5. Now, when we calculate this, it's important to remember BEDMAS. And BEDMAS says that an exponent, like 4 squared, should be done before multiplication and definitely before addition. So we're going to leave everything else except our exponent part. We know that 4 squared gives us a result of 16, 4 times 4. And then we'll have to do the rest of this as our next step. So let's do those calculations. First off, we've got 2 times 3.14 times our 16, and that gives us 100.48 for that part of our equation. And then the other part here, we have 2 times 3.14 times our radius of 4 times our height of 5, gives us 125.6 for that part of the equation. Adding those together gives me 226.08, and that would be centimeters squared. And just remembering my instructions to round to the nearest tenth, we're going to round that to 226.08. 8 is bigger than 5, so this will round up to 226.1 centimeters squared to the nearest tenth. So those ones on the front should have been pretty straightforward to do, as they are the standard dimensions and standard labeling of our objects that we had exactly in our notes. If we move on to our back side, they are still normal objects, but we have them either labeled a little bit differently or in different orientations. So if we take a look at question 4, for example, this is still a triangular prism, but in this case, the triangular prism is flipped upside down. So let's take a look at labeling a few things. First thing I want to label is my B, and I know that this is B here because it's also this side of that front triangle, and it is a side connected to that right angle. So I do know that my B is going to be 7 meters. The other thing connected to that right angle is the H of 6.6 meters. Now I know that going between the two triangles is going to be my L, so I can say that my L is 13. And I know that the other sides of the triangle are X and Y, and it really doesn't matter which order is which. Now I do know that my X here is 5.6, and that's marked over on that other edge of that same rectangle. But I also have the tick mark. And the tick mark is telling me that all of those side lengths are the same. So I in fact know that not only is X 5.6, but that Y is also 5.6 in this particular triangular prism. So let's fill in our surface area formula. That our surface area is BH plus LB plus LX plus LY. And let's go ahead and fill that in. We said we have a B of 7 and an H of 6.6. Plus we've got an L of 13 and a B of 7, L of 13 and an X of 5.6, and an L of 13 and an a Y of also 5.6. Guess let's clean that up and put that back on the page. A little bit better. So let's do those calculations. So we need to do 7 times 6.6 for that first part. That's 46.2. 13 times 7, well, I know 12 times 7 from my grade 4 timetables is 84, plus another 7 would bring me to 91. 13 times 5.6, well, I'll use my calculator for that part, gives me 72.8. Clean that up a bit. And then 13 times 5.6. And that gives me 72.8 again. Guess I should have known that part. So let's add those together. We'll take our 72.8, we'll add another 72.8, we'll add our 91, and we'll add our 46.2. That gives us 282.8 centimeters squared. Sorry, in this case our units are meters, so meters squared for that answer. Okay, the next one is also a rectangular prism. Now, in terms of our labeling, if we're following our notes exactly, we'd call the 1.1 L, we'd call the 2.2 as our W, and we call our vertical 3.3 our H. But again, in a rectangular prism, it matters less which side is which. So let's use our surface area formula. Surface area of a rectangular prism is 2LW plus 2LH plus 2WH. Let's fill those in. We've got an L of 1.1 and a W of 2.2. We've got an L of 1.1 and an H of 3.3. We've got a W of 2.2 and an H of 3.3. So let's do those calculations. 2 times 1.1 times 2.2 gives me 4.84. 2 times 1.1 times 3.3 gives me 7.26. And then 2 times 2.2 times 3.3 gives me 14.52. Let's add those together. I get my 26.62, and that would be meters squared. We want to round that to the nearest tenth, so we are going to round that to our 26.6 meters squared for question 5. Finishing up, we have our cylinder, and this cylinder is laying on its side. We know that we have our circles on the right and left, and the distance between those circles is called the height of the cylinder, even when it is laying down. The other thing I know is that they're marking the total distance across the circle. So this is actually my diameter of the circle, but I know that my surface area formula uses my radius. So we're going to divide that by 2 to get a radius of 8.3 centimeters for our radius. So let's go ahead and apply our surface area formula. Our surface area formula for a cylinder that we are memorizing is 2 times pi times r squared plus 2 times pi times r times h. So let's substitute in our numbers here. We've got our 2, pi is 3.14, r is 8.3. Need to square that. 2 pi is 3.14, r is 8.3. and h is 22.5. So let's calculate those out. First thing I need to do is my exponent, and I know that 8.3 squared means 8.3 times 8.3. If you know how to, you can, of course, use your squared button on your calculator as well. So I know that exponent part is 68.89, and then everything else is still there. $22.5, and let's do all of our multiplications. So I have my 68.89. I need to multiply that by 3.14 and by 2, and that will give me 432.6292. And then for my other part here, I've got 2 times 3.14 times my 8.3 times my 22.5, and that gives me 1,172.79. Let's add those two together. And that'll give me my 1,605 and 4,192. We're asked to around to the nearest tenth of a unit, so we're going to say that this is 1,605.4 centimeters squared. So I hope this has helped you with identifying the measurements on your surface area objects and using your surface area formulas to calculate those surface areas. Remember, when you have memorized your formula, you can just state it at the start of your question and substitute your numbers into it to complete your calculation. Now remember, the bare minimum amount of work is labeling your diagram, writing your formula, showing the substitution into the formula, and then the answer correctly rounded with correct units. Any middle steps that you do for your own benefit are fine, and I'd encourage you to do them, but the bare minimum are those 4 things for full marks. So I hope that's helped you with this topic.